Hello. Hi guys, good morning. Welcome back to the new video. And this is the minimum number of operations required to make X and Y equal. Now, you will see that in the contest, many people were actually able to do it and was pretty fast. But this is not an easy problem. This is actually a hard problem. How? Because the intuition behind it is actually hard. And you will see that the same problem, race car, is exactly same as that of this problem. So if you are able to solve it, it's just that a bit physics, as in speed equals just a distance upon time. This formula is applied in this problem. That's the only physics it is being applied, but it is roughly, or I should say 80% same as that of this medium problem. So let's see if the problem says, it says that you are given two positive integers, and again, that kind of problem we have already seen previously also, not in the race car but also in other problems, but I could not remember the other problems. This was very famous because it has been recently asked by Google, and for the recent problems, if you have not known, we are doing 100 days 100k placement challenge, in which we do most frequently asked questions. So in that we have discussed this problem itself. Not now, but maybe in the future the video will be coming in because I have made the notes for it. Cool. Now, so this problem says that you are given two positive integers X and Y. Okay, I have two integers X and Y. My main task is, okay, in one operation I can choose to do any of these four operations. Now these four operations says one thing is divide X by 11. X is a multiple of 11. Okay, I can divide X by 11 if X is a multiple of 11. Now, the first thing when I read this statement, before even going forward, is I googled what is the divisibility rule of 11. Although it is not used, but still, the first thing I thought of, maybe what if I would be able to use this divisibility rule of 11. So that rule says that if you have a number X, if I represent that number in a form of a string, or basically just write that number down, so odd places sum, the absolute difference between even places sum, that should be a 0 or a 11. If that is, then it is divisible by 11. Although this is not required, but still I told you as a knowledge for maybe in the future question of code forces, it might help you. Now coming on back, the first case is in one operation I can divide my number by 11. I can only do that if it is divisible by 11. I can divide my number by 5. I can decrement my number by 1. I can increment my number by 1. So for decrement I have three operations. For increment I have only one operations. That is the first key you should have noticed. Okay, for increment I have only one operation, which means if my X is there, I have to convert my X to a Y. Right? If I want to convert my X to a Y and my X is smaller, then I for sure will have to increment itself, which means if you can see in this example, my X is 25, Y is 30, and my rule says that you have to convert your X to a Y and find the minimum number of operations. So for sure I have to increase my X, and for increasing my X I only have one operation, which is the fourth operation, which is incrementing by 1. So for sure I will be requiring 5 operations of that last fourth operation. I will require 5 such operations to increment it, and that's the reason my answer is 5. So one very base case is, if my X is actually less than equal to my Y, then simply return Y minus X as my answer. Simply return that as my answer. Now comes the interesting part. What if bhaiya X is more than equal to Y? As you can see, X is more than equal to Y. X is more than equal to Y. Now comes the interesting case. There is no greedy way you might apply. Okay, return the minimum of operations required to make X and Y equal. There is no greedy way. You never know what operation, which path you go. Oh, which path you go. Which means, okay, if I am at this location, okay, I am at this X. Now I am saying that my Y is somewhere back. Here is my Y. On my number line, I just represented that number. Can I represent that in my number line? Yeah, I can, because you can see X and Y are in the range of 1e4. So I can. Now for this X, I have what operations? I can go to X plus 1. I can go to X minus 1. I can go to X by 5. Again, that is only possible. This X by 5 and X by 11 are only possible when X is actually divisible by that number. And I can also go to X by 11. So these are the operations. Now you see, I just want to ultimately reach to 11. That is the only case which I have. So what I can do is, okay, from my x in one operation, I can reach at these locations. So the shortest distance to reach this coordinate, which is x by 11, is actually 1. For x by 5, it is actually 1. For x by 1, it's actually 1. And the same for x plus 1, it's 1. Now, again, from these, again, I just wanted the shortest distance, which is the minimum number of operations to reach that coordinate. It is that. Okay. Now I can just do the same stuff. Okay. I am at x minus 1. Now I can again go and try for, let's say, let's name it as x2. It is, let's name this x minus 1 coordinate as x2. So I can now again go to x plus 1, x2 plus 1. I can again go to x2 minus 1, right? x2 minus 1. I can again go to x2 by 5. I can again go to x2 by 11. But, as you saw, to reach x1, I needed one step, one operation. Now, which means x2. So x2 to x2 minus 1, I will need two operations. Sorry, again, it's a one operation. So in total, from x to this x2 minus 1, operations required will be 2. And it will always be minimum. Why? Again, bhaiya, but x2 plus 1 is x itself, na? And you are visiting x again. So reaching x was a 0 operation, but you are using 2 operations to reach x back. That is a trick. Which means if something is visited, it was visited first time, and we are doing a breadth first search. We are doing a breadth, as you can see, we are doing a breadth first search. So for sure, breadth first search means visiting everything with the shortest distance possible, right? So I am visiting my every coordinate with shortest distance possible. So I am doing a breadth first search. So for sure, if something was visited, it was visited with the shortest distance. So if something is visited, please, bro, don't visit it. If something is visited, please, bro, don't visit that coordinate. So I will just simply do one thing. Okay, I know if it is visited, I will simply not visit it, and I can simply try on doing a breadth first search. Again, with this breadth first search, I am trying for all the possible values. If it is not visited, and also I'm just doing as it is a BFS, so it will always try to go if it is not visited, and also will give the minimum distance. With example, let's see with example how this can happen. So we will take a small example. Let's take the example of a 6. X is my 6, y is my 2. X is my 6, y is my 2. So the operation, how the operation can happen? Operation can happen as in, okay, I will have a 6. So I can simply go to 5, go to number 7 in one operation. I can go to 5 in one operation. I cannot do a x by 5 or x by 11. That is not allowed for me. Okay, that is it. But for here, for these, my values, which means I write, okay, this is a coordinate and the comma value is, this is the distance. Okay, to reach this, it is the minimum number of distance required. Okay, 1. Now again, from 5, I can again go and do my BFS. Okay, I can go to 6, but it is already visited. Okay, no worries. I can go to 4, 2, because 4 is next coordinate and 2 is the distance. This value plus 1. This value plus 1. Okay, for again, bhaiya, but 5 is divisible by 5. Okay, yeah, that is true, bro. I can go from 5 to 1. Okay, I can go from 5 to 1. I can go from 5 to 1, which means I'll simply go and say, okay, for coordinate 1, I can reach in the 2 time, or basically 2 operations. And the same I'll do for 7. I can go to do a minus 1, but I cannot because 6 is already visited. I'll do a plus 1. Okay, plus 1. 8, 2 is the operation. But bhaiya, okay, it seems like that we are reaching. Okay, let's see. Then this is done. This is done. This is done. Next operation is 4, 2, 1, 2, and 8, 2. As you can see, it's a simple BFS. You are simply trying for all the possible values at the same level. Okay, now you will try for 4, 2. Again, you can either go to 5, 1, but 5 is already visited. So you will try for the lesser value, which is 3, simple 3. Right? Again, I cannot do a 5 or I cannot do a 11 by divisibility. I can try, bhaiya, for 1, he can try to go to 0. Here is the case. You have to bound your range. Else you will keep on going infinitely to your left and right. That is not good. And this is what this question makes hard. this is what this question makes hard. You have to figure out how you will bound the range. So coming on back to our question, we know that okay, our values are more than equal to 1. So for sure there is no point to go less than equal to 1, right? So I will bound my range to 1. Beyond 1 I will never go. So I will not go to my 0. So that is I bounded my range. Okay, that's great. That is super great. Okay, great. Now I can do one thing. I can do a plus. Okay, I can do a plus. So I can just reach here, which is I can have a 2, 3. Oh bhaiya, first time I reach a coordinate, and that is the always the minimum distance. So to reach my 2, my distance will actually be a 3, and that's my answer. So again, now bhaiya, for left you showed what is the limit, but for right, what is the limit? What is the limit? Like, do we put this limit as 1e4 for light? No, not required. Not required. See, you are having a divisibility. You are having a divisibility. Now, why in the worst case you would try to go to right? What's the point of going to right? The point of going to right is already explained here. The point of going to right will be to obtain a number which is divisible by 5 or 11. As you can see here, you went right. You went to 55. Why you went to 55? Because 55 is divisible by 11. It is divisible by 11. It's the only reason you are going right. You are going right only and only because of you want a number to be divisible by either 5 or 11. 5 or 11. Now, if you have any number, any random number, let's say x. Let's say here in this case it was 54. In the worst case, how much I should increase that number so that it should become divisible by 5 and 11. Right? So if my number is, let's say, 48, right? So I should increase that to 50 to make it divisible by 11, and I should increase that to a 55 to make it divisible by, sorry, it is by 5, it is by 11, right? So you saw in the worst case, if you have a number x, you should just simply want to increase that number to a x plus 11. That x plus 11 is the worst case. So that you want to increase your number so that okay, it reach to a number x plus 11, and such that okay, you might encounter the number which is actually, let's say this number is s. So this number x will for sure, s will for sure be divisible by 11. That is the ultimate thing which I wanted to do, because I just wanted to reduce, because divisibility, it divides number very fast, so your number will reduce very fast, and that's what you wanted. So you just wanted to just reach to a point. Okay, I'll just try for all the possible values such that I should not miss anything. And how I will not miss anything? If I know okay, I'm just increasing by 11, so I'll just cover, okay, I'll cover all the values, which means if my number was 46, so I'm increasing by 11, which means I'm making it as a 57. So I'm just trying for 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56 and 57. I'm trying for all these values. That's it. Up till x plus 11 only, and that's how you can simply solve. You know that okay, your lower bound is restricted by 1, upper bound by x plus 11. X is nothing but 1e4. Now you will always do a BFS. Again, BFS, so such that you visit every node exactly once, so you can also maintain a visited count, and that's how you can simply get this thing solved. Cool. Let's see the code. It's pretty simple, although my code is a bit big, but you can simply make this code smaller. I'll just highly recommend if someone from you can make the code smaller and put the comments, I'll be happy to pin that particular code. Firstly, the thing which I told, that if x is less than or equal to y, simply return y minus x, because I have only one operation, which is to increase the value. Now I'm saying my x is always less than y, so I maintained my q. My q will have okay, the node value, which is the coordinate value, which is the x coordinate value, and also the distance, which is saying okay, it is a minimum distance from my x. And again, I will have to have a visited. I will keep a track of the distance. I will have that, okay, and I can simply, as I'm starting from my x coordinate, which is the x, because you know I have to start from x and reach to y, so I know I will start from my x, and then I just mark okay, x, I just push back in my q, I just make that as visited, and its distance is 0. That's it, its distance is 0 also. Now I will simply do a BFS. For simple BFS, I'll just, until q is empty, get the size until my size, which means I'm doing a level order traversal. I will find the first element of the queue, then I just get okay, what is the node value, which is node is the simple coordinate value, x coordinate value. What is the x coordinate value? And this is the distance for it. corresponding distance. This is, I just got this specific value. This is the node value, this is the distance value. Node, this is the distance. That's it. Now when I have got this, I have just 4 operations. Either I can do a node -1, I can do a node by 5, I can do a node by 11, I can do a node +1. So I just use these 4 operations. I can do a node -1. Again, the limiting condition is it should be greater than or equal to 1, because I don't want to go backwards. If it is visited is false, if it is already not visited, then you should visit that node, you should update the distance, and you should push that in the queue. I'll do the same operation for by 5, make the visit as true, distance updated, push that queue. By 11, visited, distance, push it to queue. Again for this node +1, again distance, visited, and also push that in the queue. Ultimately I will have my distance array filled, because I would have visited all the elements from the range of 0 to x plus 15. I will have visited all the elements, so I will have my distance factor filled with the minimum distance required, and that's how I can simply get this done in O of x plus y time. I can also say as O of x time. That's it. I hope that you guys are bye bye. What was that?